So Docker run is used to create and run the new container from an image, whereas Docker create only creates the container, but it's not going to start that container, but run will do both the things. Then we have Docker exec. Say using the Docker exec, we can execute a command. Say inside the container, we are executing a command. In the running container, we are going to create. Then with the Docker ps, we are going to list the containers. We are going to list the containers, whatever the containers are running. Those running containers only we are getting using the Docker PS. And with the Docker PS hyphen A, we can list even non-running containers also. We can list. Then, like we have Docker build. From the Docker file, our own customized images we can build from the Docker build. So the Docker build command also very important for us. We have using the images, Nginx, these kind of things, but our own images we can use from the Docker build. Our own images we can build from the Docker build. Then Docker pull, like we can download the images from the registry locally using the Docker pull. So push, if you have any your own image that we can push to registry, either to the Docker hub using the push. But whenever we do the run itself, if the image is not there locally, then even it is pulling the image also. Then it is pulling the image also. Then here, what is that images is, what are the local images we have is going to list all the images. Okay. Then if you want to push the image or you want to pull the image from the registry, definitely we required login. So for that purpose, we are going to use the Docker login command. So we are going to authenticate to the registry. So everyone can create your own credentials in the Docker hub, and from that we can create our own credentials, and from that we are going to log into that our own credentials. We are going to log in. Okay. So then Docker logout also we are going to perform. Then Docker search, like we are going to search the images. So we are going to search the images. Okay. So with that Docker search, whatever the images you want to search from the Docker hub, we can search. Okay. So that's we are going to perform Docker search. We are going to use. Then like Docker version, which version of Docker engine we are using, that's we can specify with the Docker version. Okay, so that's we are going to get it from Docker version. Then Docker info, like it's going to display all the information regarding the containers, kernel version, versions, all these we are getting from the Docker info. Okay, so then buildx, like instead of builder, we can use the builder also, and managing the containers, all those context, image, network, all these also different commands. On top of this, we can create these all the commands we can use. Then we don't use the individual Docker container. We have the Docker swarm. So using the swarm, we are going to connect. So using the swarm, we are going to connect to those containers we are connecting. Okay. So what is the meaning of swarm is like group of Docker engines as the cluster we are going to manage. So those all we are getting as the swarm environment. Okay. Then we can attach maybe networks, all those also we can attach. And commit, we are using already a container is running. From that we can create our own image. So we can create an image from the commit, we can create an image also. So yesterday here we have we discussed till this. So Docker exec we are using is for to execute a command on the container, but intelligently we are using to enter inside the container. We are entering inside the container. So here we have Docker exec hyphen it. Then we have like IT stands for interactive, and the TTY mode, container name or ID, then bin bash. So using this, what's going to happen is we are entering inside the container. We are entering inside the container we are entering. Okay, so Docker exec hyphen IT, container ID, bin bash we are going to enter. Then, so using the Docker run, we are creating the containers. Then Docker CP we are using to copy the file. Say suppose assume I have one file jenkins.var. I want to copy inside the container. Then container name colon then var lib or maybe like wherever we want to copy user share Tomcat. Okay. So to that like web apps folder I want to copy. So what is this doing is like Jenkins.var is on our local machine, and using the Docker CP, we are copying that inside the container. Okay, normal SCP command we are using to copy the files, but here what we are using? So by using the Docker CP command, from the host to inside the container, we are going to copy that. From the host to inside the container, we are going to copy. Okay, so that is the purpose we are using Docker CP command. Then like another important command is Docker build command we have. Say we are going to create our own customized images. Okay, so those images we are create from the Docker file. Okay, so from the Docker file, if we want to create an image, okay, that's our own requirements we have. From that image, if we want to create, then we are going to use the Docker build command we are using. So Docker build command we are using. Okay, so with this, what is the advantages? With the Docker build, we are going to create our own images. We can create with our own instructions. We are getting created. Our own instructions we are getting created. Okay, so then like already a running container is there. So the container wise, I want an image. Then we are using Docker commit. Okay, so in which use case you are using Docker commit? So in which image we are using Docker commit? We have already we have already like a container is there. From that I want a image. I want to run similar kind of containers. At that moment, I'm going to commit that. Say what is the difference between Docker build is we don't have any container. We want to create our own customized image. Then we are using Docker build. From the Docker file, we are building. Then Docker commit is, so in which use case we are going to use the Docker commit? We have already a container is there. From that, we want to run that. Then we are going to use the Docker commit command. Docker commit command we are using at that moment. Okay, so then like Docker CP, we discuss copy files and folders between the container and local file system. Okay, so then we'll create a new container. Okay, then like on the container file system differences, those we can confirm. Okay, and the Docker events will show all the events it shows. So Docker events, okay, so that's sorry, small typo is there. So whatever the events happened, all these, say if you run all these commands in the real time, like we can run or we can troubleshoot at the Kubernetes level, we can understand those. At the Kubernetes level, we can understand all these. Okay, so normally Docker events is going to display what are the events happen on the Docker level, recent events. If nothing is happened, that's the reason it's maybe not displaying. Even in the Kubernetes also, while troubleshooting the recent changes, all those we are going to get it from the events itself. Okay, then one container is there. That container I want to tar format, I want to archive. At that moment, I'm going to use export option. I can export that container file system by using the export option. And history will show the image, what are the changes, what are the layers has been added. All those will get from the history. Okay, then import also the contents from the tarball. Like we can create a import also, like we can do. Then like a export and import we can do it. Then inspect all the details it is going to show. All the details it is going to show it. Okay, so all the details we are going to get related to like that image level or container level, network level, volume level, all those details we are getting. Okay, then we can kill that container also. So we can kill that container also. Then load an image from the tar archive. We have like we stored a tar archive format. From that we can load an image. Then logs are important. We are going to fetch the logs of the container. Even for the troubleshooting purpose, even we are going to use those like those logs also we are going to get it. In the Kubernetes, we are using kubectl commands. So all those mostly we are going to use. In the Kubernetes also, all these commands we are going to reuse. Okay, so all these commands we are going to use from the Kubernetes. But if you practice at the Docker level, then very easily we can understand from the Kubernetes wise we are going to understand. From the Kubernetes wise, we are going to understand all these. Okay, so then like here we have pass. So all the process it's going to pass all the processes whatever running on the container level, and we can use unpass also. Okay, then port, like what are the mappings we have, all that it's going to display. So we use 80 to 8080, like that, all the port mappings it goes. And we given a name, we want to rename that, we can use the rename command. And restart, we can restart those containers also. So that is also one of the lifecycle kind of command. So using the restart, we can restart one of those containers. Okay, so RM, like we can remove the non-running containers. If we want to remove the running containers, we need to use a -f option, like forcefully we are going to remove. And what is the command with the RMI is, like the images are getting removed. Images are getting removed. And what is the meaning of save? Like we can save those images in the tar format. Using the load, we can extract them. Start and stop, like those also lifecycle commands. We can start or stop those commands. And stats will display all the resource usage of those. Okay, so then tag is there. Tag is like we can give our own names also, like for the tags we can provide. Okay, so to the image we are going to provide the tag names. Then top running process, whatever running inside the container level, it goes show the PIDs, all the process IDs is going to display. Set top and stats are the monitoring kind of commands. Logs is for the logging. But in the enterprise environment, we are going to use Prometheus, Grafana, ELK stacks, APM tools for this. Manually, we don't run. Okay, then pass, unpass we can do, and update will do all the configurations of the updates we can perform. Wait, like if you have any dependencies, those all, like it's going to block that. Okay, so these all the different commands we have. Most of the important things we have discussed, but build, commit, all that at the Docker file level we'll discuss. Volume, networking, those also will discuss. Yeah, any doubts on this? On these commands, any doubts? Yeah, any doubts? Yeah, Kubernetes is not a containerization tool. On top of containerization, orchestration tool is Kubernetes. Okay, so now here Docker, Containerd, Podman, Runc, these are the different container kind of environments. On top of that, we have the orchestration kind of tools, Kubernetes, OpenShift, Apache, Mesos. Okay, even Docker also having Docker Swarm. So these all the different orchestration kind of tools we have. Yeah, any other doubts? Any doubts? Okay, so we need to understand even the Docker level. We have the concept of Docker volumes and networks also. So what is the concept of Docker volumes is by default the data inside the container is not persistent. Okay, that means if the container is stopped or if the container is deleted, the data is persistent. Even in the AWS also, we have an EC2 instance. We are going to store that in the EBS volumes we are storing. Even if the EBS EC2 instance is deleted also, we can keep the EBS volume can be kept. But by default, it is getting deleted. But we can store that EBS volume or we can have a backup or snapshot of that. In the same way, we have a Docker, we are attaching the volumes to the Docker. Okay, what is the advantage of attaching a volume to the Docker is like the data inside the container is persistent. The data inside the container is persistent. With that, what is the advantage is? So the data inside the container is persistent. With that, what is the advantage? Like even if the container got deleted or container crashed, we want that information that's we are persistently storing in a Docker volume. Okay, in the Kubernetes, we have the same information is getting stored in the Kubernetes like persistent volume. There we are calling as PV and PVC we are calling. PV and PVC we are calling. Okay, so normally we are getting those details from like in the Docker, we are using the volumes. Okay, so now in the Docker volumes, so we can store that Docker level. We are using Docker like a volume. We can use inside the Docker area itself in a volume. It's getting stored or bind mount. We can use or we can use for the Linux systems TMP FS also. Okay, mostly we are using Docker volumes itself. Inside the Docker volumes, we are going to store those details. Or other than that, if you have any file system, then we are going to use that bind mounts and we are going to store that in the TMPFS. We are going to store it in the TMPFS. Like that's a temporary swap memory kind of thing. So temporary swap memory kind of thing, we are going to use it. Okay, so then like like using the Docker volume, we are creating a volume. Okay, so from that volume we are attaching to the containers. Okay, so then I don't want to attach. I have already my data in my in my var lib or already it's in my like a user Tomcat or user like home or home directory we have with the Ubuntu directory we have. Like this, if you have, then it's not in the Docker volume. That's our own Linux file directory. If you want to attach, then we need to use bind mount. And the TMPFS when we are using is, the TMPFS we are using is like I don't want to store in the like volume or bind mount, then we are going to use that memory kind of thing, some temporary memory kind of storage we are using. So that's called as TMPFS. Okay, but that doesn't support for the Windows, only for the Linux it's going to support. Okay, so then like how we are going to access that container, that is going to be decided by the network. Okay, we are getting lot of network drivers we are getting. So what are the network drivers also is very, very important interview scenario, and even to understand the Kubernetes also. Compared to Docker, 3 to 5 times complexity is there for the Kubernetes. To understand that Kubernetes, where the base is Docker. Okay, so then here we have the networking, like we have the different network drivers for the Docker level. We are going to use the bridges there. So what is the bridge? By default, if we don't use anything, we are getting the bridge network. And with the bridge network, what's happening is we can access the container from outside also we can access. Means like using the, like we used yesterday, 8080:80, the host side we are using 8080, and that is using the bridge network, it is redirecting to 80. Then if I use the host, I no need to bridge it. By default with the host port itself, that container is getting accessible. Okay, so by default whatever the host port itself, directly we are attaching to container itself. So can you guess in the Docker environment, bridge or host, which one is coming by default? By default, which one we are getting? By default, if you don't configure anything, default we are getting bridge itself. Okay, so by default, what is the network we are getting is bridge itself is the network we are getting. Okay, so then like here after this, we have none. If I use none, I can't access that container at all. From either from the host side, from the outside also, I can't access. I want to give an isolated kind of environment, then I'm going to use the none kind of thing. I'm going to use none for that purpose. Okay, then here we have one more is there, overlay. So overlay is the default in SWAM environment. So in the SWAM meaning is we don't have only one Docker engine. So multiple Docker engines we are merging into single entity. There we are calling as the SWAM. In the SWAM node to node communication, by default bridge doesn't support. There we are going to use none we are using. So none we are going to use it. Okay. Sorry, overlay we are using. In the SWAM environment by default we are getting, okay, overlay. Then we have two more also, Mac VLAN. So in the Mac VLAN, for every container also we are getting Mac ID. Okay, so then we have IPv LAN also is there. We can allocate not only IPv4, IPv6 also we can allocate. So by default, we don't get the MAC ID for every container, but in the cloud for every VM, we are getting a MAC ID. But you want your own MAC ID for your container for auditing purpose like that, then we need to use MAC VLAN kind of driver. Okay, so IPv6 and IPv4, if we want to use, then IPv LAN we need to use. Okay, so these all the different. So these all the different type of network drivers are supported. Okay, so can you tell me what are the network drivers we have? So we have bridge, and by default we are getting the bridge. Then we have host. Okay, none, overlay, MAC
One
VLAN,
VLAN, IPv LAN.
IPv LAN. So these are all the different type of, and by default in the Docker environment, we are getting bridge, and in the Docker Swarm environment, we are getting overlay we are getting. So in the overlay, by default, we are getting. Okay. So then what is the MAC VLAN is our own MAC ID also we can get it, not our own MAC ID. For every container, we are getting a MAC ID. Okay. So then IPv LAN, both IPv4 and IPv6 we can allocate. So these all the different type of like network drivers are supported, and by default we are getting a bridge, and there is one use case, try to understand. We can create our own user defined bridge networks. Okay, that means not like by default we are getting a bridge, but we are not using that. We are creating our own user defined bridge we are creating. What is the purpose of this is, I have two containers and those two containers want to communicate with each other. That means I want a link. In the very old scenario is explicitly we need to link the containers. So suppose assume I have one Tomcat container and Tomcat container want to communicate with MySQL kind of container. By default, both the containers won't get communicator. So then here I want to link it. That's not a requirement in the new versions. What is the thing we need to do is we need to like both the containers bring it to same network. That means use the user defined network, bridge network, then both are getting communicated. Then both are getting communicated. Can you tell me again? Like what is the meaning of linking? What is the meaning of linking? So I have two containers and both the containers I want to explicitly
communicated.
say explicitly the both want to communicate. At that moment we are going to use like user defined bridge. By default we are getting a bridge network itself, but we are creating our own network also. That bridge network we are going to use. Okay, but Kubernetes having more powerful networks compared to this. But if you understand technically at the Docker level, on the Kubernetes we can understand, we can troubleshoot. So what is the difference between this is, in the Docker level we are managing at individual level, but Kubernetes will manage some thousands of containers, their network, storage. We don't manage individually. At the bulk level we are going to manage. That's automatically creation, updates, rollbacks. All this also is going to happen at the Kubernetes level. Those are going to happen. Those are at the Kubernetes level. Those are going to happen. Okay. So then another very important, that's even if you use the Kubernetes, one thing what it required from the Docker is a Docker file. Okay, so we need to have very good knowledge on the Docker file. Okay, so whatever the videos I'm sharing, go through 2 to 3 times. Okay, if you understand Docker file, even in Kubernetes environment also, we are building those images through the Docker file itself. So what is the Docker file is? Docker file having the instructions, we are specifying some instructions. From that instructions, we are building an image. We are building an image. Then we'll scan that image for the vulnerabilities, all those. Then we'll tag it with the appropriate name. Then we'll push to registry. That registry may be, that's maybe Docker Hub, or like we may have in the AWS, we have ECR, Elastic Container Registry, or Azure Container Registry, or we have DTR also, Docker Trusted Registry. So to any of the registry, we are going to push that image. Then either from the Docker we can run, or from the Docker Compose we can run, or in the Swarm environment we can run, or in the Kubernetes, we can run that. So for all these use cases, we are going to use For all these, we are going to use like Docker file. And in your project, if you have 20 microservices, so assume in your application, we have 20 microservices. For each microservice, you should able to write down Docker file. So you should able to write down one Docker file for each microservice. Okay, so that's one microservice we need to write down. So for 20 microservices, we are going to write down 20 Docker files we need to write. Then we need to build it. Then we need to scan them, tag them, then push to registry. Okay, so these all the operations we need to perform. So for this, we are going to build it through
Docker file.
Docker file. Okay. Any doubts on this? Okay, said first practice all the Docker commands. Yesterday I shared videos, I've gone through those. Yesterday I shared some videos, right? I've gone through that. So please finish those networking and those. And the Docker file, today I'll share 2 videos. So definitely need to go through 2 to 3 times. Everyone, Docker file, like if without having Docker file knowledge, we can't survive in the Kubernetes environment also. Okay. So till this, everyone need to finish because no one watching any of the video. Okay, so first to keep the interest towards the technology, automatically job comes. Okay, so don't keep the interest towards the job. It never comes. Keep the interest towards the technology. Because I have taken a lot of batches and never seen people with this kind of interest levels. People used to do lot of discussions, lot of questions. They used to do everything. Even if you go through those videos, you will understand that. I don't know the problem with you. Okay, no one opening also the single video because I'll get that details. I'll get how many people opened, all that records. I'll get that. Okay, but for Docker file, multi-stage Docker file, just go through today. Okay, now itself I'm sharing. Everyone finish those videos immediately. 2 to 3 times finish, and very important even from the interview wise also.
Okay, sir.
Okay.
Okay.